Welcome students. Welcome to the lecture series on laser, which is a part of your module optics. So in this class, we are going to discuss about various kinds of lasers, say ruby laser and helium neon laser. So actually in this slide, I am going to demonstrate how actually our laser works. So let's see. So let's say you have 3-level system. So your electron is in the ground state. At the first step, your electron will be in your ground state. So it gets excited to the higher energy state, which is a short-lived. And how it gets excited? By optical pumping or thermal pumping or electron collision, like this kind of processes. Then what will happen? As it is a short-lived state, this electron will decay to the next lower energy state. Okay. Now this is a metastable state. That means this level has comparatively higher lifetime compared to this ground state and this excited state. It means you will get a population inversion. How? Because the electron coming to this metastable state will stay here for a certain amount of time, and then you can accumulate electron where the number of the electron is greater than the ground state. So what will happen? You will get a population inversion. That means the population in the metastable state will be greater compared to the ground state. Then this electron from metastable state decays to the ground state by stimulated emission. So you will hit this metastable state electrons by some other photons, and you will get 2 photons at the output, and that will be actually your laser light. Okay, so this is how your laser works. Now you see, your electrons are decaying to this state and you are getting lasers, and these lasers are reflecting back in these 2 resonator systems. It is a 2 optical mirror which I have discussed, and it is getting reflected back and forth inside this system, and you are getting amplification. You are getting amplification of light, and after that your laser is coming out. Okay, so this is how actually your laser works. Now let's say ruby laser. So this is a schematic diagram for your ruby laser. Here there is 2 excited states which are short-lived. So you excite these electrons to this short-lived state. So it will be excited by optical pumping. Then after excitation, it immediately decays to the metastable state. So here is your metastable state. So you excite the electron to the short-lived state by optical pumping. Then it decays. It immediately decays to the metastable state, and there it stays for some time, so that you can have a population inversion. Then it decays to the ground state by stimulated emission, and the wavelength of it is 6943 angstrom, which is the laser wavelength of ruby laser. So your ruby laser is a 3-level system. This 1, 2, 3. And here your host material is Al2O3 and the active material is Cr2O3. Actually your chromium atom replaces the aluminum atom for the lasing action. So the active material for your ruby laser is chromium O3, okay, Cr2O3. So this is another picture of ruby laser. This is a laser tube. Here you have xenon flashlight which gives your optical pumping, and from here you get your laser beam coming out. So inside it there is a ruby rod. So it consists of a single crystal of ruby with flat end, one completely silver and another partially silver, so that it can act as a resonating system, and by reflection you can amplify the laser light. Now coming to the helium neon laser. So this is another schematic diagram of helium neon laser. So actually helium neon laser was first developed by Ali Javan, and it is a gas laser. So it was first developed in 1961. So your ruby laser is a solid laser and your helium neon laser is a gas laser, and it is very popular and widely used. The transition of neon atoms provides the laser action. So here your neon is active medium, while helium is added to the gas mixture to facilitate the pumping process. Now you can see how it works. By electron collision, you excite the helium atom to the excited state. Then there is a inelastic collision or there is an energy transfer, so your excited electrons goes to the excited states of the neon, then it decays to this state, okay, these two states. So these are your metastable states, these two. Then there is immediate decay from this CP state to the ground state. So why this is metastable state? Because these transitions are forbidden transitions. That's why it becomes metastable state. Okay, what is forbidden transition? You should know that there will be some combination of some spin difference between the electrons where electron transition cannot take place. So these transitions will act as your laser transitions. So here you have your helium and neon gas with a ratio of 5:1, and the laser transition energies are 3391 nanometer, 543 nanometer, 632.8 nanometer, and 1158 nanometer, and 1152 nanometer. And in between, among them, these 632.8 are most popular. So this is how your helium neon laser works. You excite the electrons by this electron collision, then it transfers to the neon excited state, which are metastable states. It decays to this state, so there you get your population inversion, and then it just decays because these states have shorter wavelengths. So these are your metastable states, these are your short lifetime states, and it is a 4-level system. So helium neon laser is a 4-level laser. So what we have learned today about lasing action, how a ruby laser works and how a helium neon laser works. Thank you.